All right, so here's my attempt to give you guys a lesson online. I checked some stuff online. Nothing was really exactly what I wanted to show you guys. So here's something on exponential relations. I hope this helps. So first of all, even when we did quadratics, I always want to show you guys there are four different things that I want you to learn, and I need you to go back and forth between those four things. So they are the scenario, the table of values, the equation, and the graph. So if I give you a graph, you should be able to give me a scenario that fits that graph, a table of values, and an equation. If I give you an equation, you should be able to give me the scenario, the table of values, and the graph. If I give you a table of values, you should be able to give me an equation, graph, and scenario. And if I give you scenario, you should be able to give me a table of values, equation, and graph. And if I give you a graph, you should be able to give me scenario, table, you know, all the different combinations. All right, so let's start off. I'm going to give you guys a scenario. This is a scenario. If you noticed, mathematicians who studied exponentials are now very valuable in the world because we have this coronavirus you guys have probably heard of. Anyway, so the scenario here. Let's say one person back in early December had a virus. And each week, so just once a week, everyone with a virus spreads it to one other person, just one new person. So every week, the virus doubles in size. So if there's one person, for example, let's go over here. If one person has it, and after 1 week they spread it to one other person, well now, one person started with it. After 1 week, two people should have it. After another week, now each one of these people spreads it to one person. If you notice, that doubles it. So it's times 2. Now you should have 4 people. Now if one more week, each one of these people spreads it to someone else, just to one other person. Now we have 1, 2, 3, 4, 5, 6, 7, 8. Okay? One quick way of doing that is just multiplying by 2 each week. Okay, so after 4 weeks, you'll have 16 viruses. Okay? All right, that seems pretty easy. So in this case, our table of values, after 0 weeks, so it hasn't even started yet, you just have that one dude with the virus. After 1 week, he accidentally spread it to one person, and now you have 2 people with the virus. After 2 weeks, now you have 4. After 3 weeks, you have 8. 4 weeks, you have 16, and so on and so forth, okay? The equation here, now this is what we learned online, and we always know that it's going to be y, or sometimes they use f of x to show that we need an x value here, is equal to, it doesn't matter if you use y or f of x, is equal to a times b to the power of x, where a, you have to fill in initial value. That's the value you started off with. Whether you're talking about the value of a car, whether you're talking about the value of your house, whether you're talking about the number of people with a virus, no matter what it is, the initial value is the thing that you have when the time hasn't started yet, at 0. Okay? Your B is your growth rate, or your decay rate. Okay? If your growth rate, if it's a growth rate, that means it's getting bigger and bigger and bigger. If it's a decay rate, it's going to get smaller and smaller and smaller. Your growth rate is going to be greater than 1. Your decay rate is going to be between 0 and 1. Okay? Oops. So B has to be greater than 1, and B has to be between 0 and 1. So if your B is a small number, like 0.5 or 0.6 or 0.7, then this final answer is going to get smaller and smaller and smaller. In this case, our growth rate is 2 because it doubles. Times 2. Times 2, times 2, times 2, times 2. And our initial value is 1 because it started with only one person. This is our equation. So as you learned from online, the equation always looks the same thing, the same way. It's something equals initial value times your growth rate to the power of x. All right, so here's our equation. So now we have our equation. We have a table of values. Let's just see if these two things agree with each other. We're going to say when x was 4, our equation should work with every single one of these numbers. So y equals 1 times 2 to the power of 4. Let's go on our calculators and see. Can we get a close-up here? 1 times 2 to the power of 4 equals, and sure enough, it equals 16. Okay, so now I could actually answer, now that I have the equation, that's awesome because I could answer our question. After 22 weeks, how many people will have gotten the virus? All right, let's go to the equation. 1 times 2 to the power of 22. You just plug in 22. And the answer is 4,194,304 people. All right, that's a bit, right now we only have about 1.5 million. So maybe my equation's not perfect, by the way, you guys know that, right? Let's say 1 times 2 to the power of 20 is a little over a million. So maybe we're 1 times 2 to the power of 20.5. Yeah, that's kind of cool actually, because we are about 20 and a half weeks away from when it started, and the world really does have about 1.5 million people who have been infected. So this equation isn't all that bad, to tell you the truth. And so the answer here, I'm going to extend my x, y, I'm going to extend my table of values. At 20.5 weeks, we had 1,482,000. 910.4. I don't know how you can have a 0.4 person. I'm just going to put approximately there. After 22 weeks, which is the question we're asking, 1 times 2 to the power of 22. Yeah, I wonder if this is how many we're going to have in a couple weeks. 4,194,304. Make sure you comment on Google Classroom that I'm an absolute genius if this is the number of people who have it in 2 weeks from now. All right, our equation again is y equals initial value, growth rate to the power of x. And let's do a graph. The graph is just basically redoing the table of values. Here's my y-axis to tell me how many people have the virus. Here's my x-axis to tell me how long it's been. After 0, let's say this is, I'm going to go up a really huge number. I'm going to go up by 100s, 200, 300, 400, 500, 600, 7, 8, 9, 1,000. 1, 2, 3, 4, 5, 1,500. 1, 2, 3, 4, 5, 2,000. All right. After 0 days, there was 1 person. That's like a small number here. After 1 day, you only had 2 people. Still really small. Oh. After 2 days, you only have 4 people. 3 days, 8 people. Still really small. 16 people. 1, 2, 3, 4, 5. After 5 days, you have 32 people. You notice it barely grows at all. No big deal. So now you're looking at around the world going, oh my gosh, what's this social distancing thing? I don't have to do anything. I don't even know anyone with it. There's only 32 people in the world who have this thing. After 6 weeks, I don't know, I think I was saying days, but it's after 6 weeks. Oh, now we have 64 people. Okay, no big deal. It's nobody I know. They're all in China. After 7 weeks, oh, now we have 128 people. After 8 weeks, now we have 256. After 9 weeks, oh, now we have 512. Okay, still, I don't really know that many people. 512 around the whole world, that's not very many. I'm sure I'm not going to encounter any of those. Oh, now we have 1,024. Oh, wait, that's getting pretty big. After 11 weeks, now we got 2,048. There we are. And after 12 weeks, we are off the charts. 4,000 is twice as high as this. We're at 4,100 almost. And as you can see, it's very normal for people who don't understand math to say, oh my gosh, there's only 1,000 people, no big deal. But look where this line is pointing, right? When you got to 13, 14, 15, 16, 17, 18, 19, 20 weeks later, now we're talking millions of people with this virus, okay? So that's exponentials. I'm gonna do real quick, I'm gonna change it a little bit, the scenario. Instead of 1%, I'm gonna change this. This time I'm gonna give you a different equation. I'm gonna say y equals 2,000 times 0.75 to the power of x. Okay, now we've got a new thing. Now this number is below 1. So it's not going to be getting bigger and bigger and bigger. It's going to get smaller and smaller and smaller. When I multiply something by 0.75, it actually makes the number smaller. This is called exponential decay. So let's see what happens over here. After 0 weeks, we know we have 2,000. That's the initial amount, remember. Initial amount. And if I plug in a 0 into this equation, I'm going to show you that it should equal 2,000. So I have 2,000 times 0.75 to the power of 0 equals 2,000. Okay, of course, anything to the power of 0 is going to give me, this is going to just equal 1, and so 2,000 times 1. All right, now I'm going to put in 2,000 times 0.75 to the power of 1. Oh, now we have 1,500. 75% of 2,000 is 1,500. Now we're going to do 2,000 times 0.75 to the power of 2. Oh, now we're at 1,125. 2,000 times 0.75 to the power of 3. 843.75. Okay, and to the power of 4, 632.81 approximately. Now, what kind of a scenario could we build with that? All right, let's say I bought a car. So Porto bought a car, and the initial amount is $2,000. So for $2,000. So the value of my car right now is $2,000. Each year, it depreciates by, so if it's worth 75% of its original value, then that means it depreciated by 25%. By 25%. Okay? Because it's no longer worth 100% of its value, it's only worth 75, it went down by 25%. So each year it depreciates by 25%. How much is it worth, let's say, in 10 years? So that would be a nice scenario that you can build. Notice all I care about is my initial amount is listed here. That's my initial amount. And there's a way of showing that the growth rate. So my growth rate is 0.75, which means it actually went down by 25%. Okay? And now, so Porto bought a car for $2,000. Oh yeah, we just have to extend my table of values one more spot so that I have the answer of 10 years. I have my equation already. So let's say 2,000 times 0.75 to the power of 10, and my car is worth $112.63. There you go, $112.63. That means if I need a brake job, I'll probably just throw the car in the dump instead. Okay, graph it, and then we are good to go. All right, it starts off at 2,000 right here. After 1 week, we're at 1,500. After 2 weeks, we're at 1,125. After 3 weeks, we're at 843. so 843. After 4 weeks, we're at 632. There we go. After 10 weeks, we're at 112. All right, and you guys can kind of see how this graph is going to get smaller and smaller and smaller. Okay, so you can see that exponentials aren't necessarily growth. Sometimes they are decay. All right, if it was growth, you would see that it would go up that, well, actually it would go up that way like the graph we had before. Okay, I'm going to also post some work for you guys to do online. If you have any questions, please send them on Google Classroom, and I will communicate you more from now until Friday. And I want you to take a weekend off. Don't do anything Friday, Saturday, Sunday, or Monday, and I'll see you guys on Tuesday. All right, ciao for now.